Okay, here we go on associative property. So hopefully this will help you out to understand associative property before you take the exam. I can tell you watching this will really make a difference for the exam. All right, so first thing I should say is the commutative property, which was a discussion prompt right before this one. Every group got the right answer. So commutative property you guys were good with. Associative seems to be a little bit harder, and I think that's because it involves 3 rather than 2 letters. So here's the deal. Commutative and associative property you guys have probably learned every year since like 3rd grade. And you probably memorized them for the test. And maybe you understood them completely and maybe you didn't. So this is an attempt to get you away from just the standard memorization and really trying to understand what does it mean to be associative, what does it mean to be commutative. All right, so anyway, let me start here. So ignore the table for a second. Let's talk about regular numbers, regular operations that we know about. All right, so I'm going to do 2 times 4. Let's do times 5. All right, so there are 2 ways that I could go about getting this answer. Okay, so I could do 2 times 4 and get 8, and then I could multiply by 5 and get 40. Okay, or I'm going to start with the exact same problem, and I'm going to multiply those 2 numbers first. So I'm going to do 2 times 20. 2 times 20 is 40. So it's not about switching the numbers around this time. The numbers are staying in the same place. Yeah, you're moving the parentheses, but that, I don't know. I think when they talk about parentheses that can be a little bit misleading. You've got to do 2 operations. Doesn't matter which one you do first. That's what it boils down to. With multiplication, it doesn't matter which you do first. You can do the 2 times 4 first, or you can do the 4 times 5 first, okay? And it's going to get the exact same answer. All right, let me grab my eraser here. All right, so hopefully you know addition would be the exact same thing, okay? If I did addition with those 3 numbers, I could switch the order, not the order of the numbers, but the order that I did the problems in. So I could do the first addition, then the second, or then the second, then the first. So that is also associative. Let me do an operation we know and see whether that is. So let's try subtraction. So let's do 10. Oop, I still have. Okay. Let's do 10 minus 8 minus 5. All right? Start here. 10 minus 8 is 2. 2 minus 5, negative 3. All right, let's try it the other way. 10 minus 8 minus 5. This time I'm going to do that second subtraction first. So 8 minus 5 is 3. 10 minus 3 is 7. I don't get the same answer. And since I don't get the same answer, subtraction is not associative. Okay? So I only need, like some of you guys use perfect language in these prompts. I was so proud of you, saying it only takes 1 counterexample to disprove something. So this is a counterexample that shows subtraction is not associative. All right, let's jump into this table here. So I've got 2 examples here. So A, it's a number, but it's not one you recognize. So you have to go with it. I know it's weird. Theta is an operation, but you really don't know what it is. You know what the answers are, but you don't know how they're getting the answers. Okay. So I'm doing A, D, and then C. Okay. So here's my problem. A, D, and C. So I've got 2 thetas that have to happen. All right, let's try it where I do the first 2 first. All right, so I got to use my table, and I do A, and I go over to D. All right, so that answer is B. And then I do D, theta C. So I start with D, I go over to C, and I get an answer of B. Right? I'm going to write the exact same problem. Right? This time, I'm going to do the second theta first, and then I'll do the other one. All right, so D, erase. All right, so D theta C, let's try blue here. D theta C, that's B. And now I've got A theta B. And I get B. All right, this would show that it is associative. Hey, guys, it's only one example, though. It is possible to do one and it works, and then you do another one and you find out, okay, it doesn't work after all. It only takes one to kind of like ruin the whole thing, right? One spoiled apple ruins the whole bunch. Is that a thing? I don't know. Anyway, let me do another example. So let's, I can play right down here. All right, let's do, I'm just making this up, totally at random. Let's start with C, and then do A, and then do B. Okay? So, I'll do CA first. Erase, because I think maybe that'll help. All right, CA. I start with C, I go over to A, and I'm getting C. All right. Now I'm going to theta that with B. So I'm going to start with C, and I'm going to go over to B this time. So I get D. All right, answer of D. All right, so same exact problem. C, theta, A, theta, B. Do it with those two first. All right, so I do the A theta B first. All right, and one more time. All right, so A theta B is B. And C theta B is D. Alright, got the same answer. So if it were me as a student, I'd probably do one more, which I'm not going to do. But I'd do one more, and if I got that one to turn out right, I'd be like, yep, it's associative. Alright, so expect something on the exam, really similar to this. And I hope you have watched to the end of this, because watching this will help when you get to that exam question. Have a good rest of your day, guys. Bye.